Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Getting Started Gesture-Based Application. Our guest speaker today is Nitesh Vyas, Manager Technology at Sapient Corporation. Nitesh Vyas is Manager Technology at Sapient Corporation Private Limited, Gurgaon. He has worked on a variety of applications working at Sapient since 2005 and has performed multiple roles from design and development of complex applications to develop and lead the product. He has extensive experience in web-based application development in Microsoft technology. He has experience working on marketing services solutions, which includes a variety of applications from social media to lightweight platform to creative applications. He is currently associated with the Marketing Services Technology Group in Sapient and has been working cutting-edge technology like gesture-based app, graphics programming, etc. So without further delay, I introduce you all to our guest speaker. Over to you, Nitesh.
Okay. Hey, good afternoon all. So before we start, have you ever imagined or been in a situation where you are working in your cubicle, and you are working on so complex thing that you don't want any interruption, and what happened? Your colleague just came up from nowhere and he was started looking at your screen. At that point of time, something came to your mind. Oh, what if I could have had some simple gesture who could have just, swapped the screen to hide whatever I was working upon. So now we have the technologies, we have the tools available for us to do those things, and we are going to talk about those applications, essentially gesture-based application. Quickly touching upon the agenda that we're going to talk about is how the human interactions with computers has changed in the recent years. And then we're going to talk about the natural user interface, what is natural user interface and how we're going to implement it, and then specifically the gesture and gesture-based application and what are the challenges involved with it and where to go next. And okay, so imagine that what kind of application you have been working upon or using in last 10 years or so. Most of the time we were just involved in the console-based application where you are having a very black and white screen with some data to it, and you have to have a very precise key input to operate on those applications. If you don't put your input in that way, your application isn't going to work. So you have to train yourself to use those applications. So that was something we have to learn each and every time we come up with a new application. We have to train ourselves. So that was something which was a problem in the console-based application. Then comes the era of grid-based application. There is some problem with the application. Okay. Yeah. Yeah. So I was talking about the console-based application and the challenges with it. Then comes the graphical user interface. in the graphical user interface, you were given a little bit of a breather when you was using your keyboard and mouse to interact with the application. You can scroll over your mouse to any place and work on the fields those are present on the screen. But again, on those kind of applications, you have to train yourself, and that was again a challenge for us. What if some kind of application we would have had which gives us the flexibility to 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 behave the no, to behave like a normal human being, like I'm just posing a gesture, saying hello to someone, or doing something which I normally do, and the computer is reacting to those inputs. What if? So that is something is called as natural user interface, and the application based on those are naturally gesture based application. So this is the dawn of the era where the mouse, no cursor, no touch was there. When the natural user interface has started, you can see now you have the devices, tools and technology available to you where you can just use touch-based inputs to do something. Remember the days when you were just playing Sudoku on your newspapers, you just crossing with the pen and paper. Now the same kind of feeling, same kind of interaction you can do on those devices available to you. Similarly, you can use your hand movements to interact with your application on your device. And there are application which is without touch as well, which is essentially the gesture-based application where there is you are providing with no keyboards, no mouses, no touch, but only you have your body parts, your hands, eyes, etc. And using those, you can control the behavior of an application. That is what is the gesture-based application we're going to talk about. So what is gesture? Before I describe the gesture, let's see. So if you look at those pictures, in one picture, the lady is waving the hand or saying stop, or using both the hands to kind of expanding or minimizing something. So gesture is nothing but the movements of your body part to do something. It is very similar, the gesture is very similar to what you do in normal day life, like waving your hand and all. But strictly if you define certain path to it, you define a particular gesture. Like waving your hands from left to right and a horizontal move is kind of saying waving your hand, or pushing your hand towards in front of you is kind of attacking something. Those are the gestures. And there are other kind of things as well, other kind of inputs as well, which is postures. Postures are something where you have a steady state of your body parts, something like you are standing, something you are just looking at something. It's kind of no significant movement of your body parts. That is what we call as postures or the poses. So those two terms, gestures and posture, are very significant when we develop the gesture-based application, and the implementation changes or the design of the application changes pretty much based on what you are trying to do. So it's okay that I am waving in front of a computer. It's okay that I am saying hello. But how am I making computers respond to those gestures? Was it there in the computer that is doing something for this? It's very, very simple. You help computers see those things, what I'm doing, and the computer will then process the data and extract the information out of it and do something with that. Maybe doing something, creating some application or something. But definitely that will happen. Okay? So how computer sees the things? Right, definitely. Like humans have senses to watch, to listen, to feel something. Computers have been grown with those senses in terms of different gadgets and all. Like they can listen when you speak through the microphone, they can listen to it. They can watch using the cameras that we fit into the computers, to the machines. And they can speak as well. They have the speaker out of which the voice is, right? So we have given machines the necessary senses using which they can communicate to humans. And how do they use them? So how do humans use their gadgets like eyes? So using my eye, what I do, I normally look at something and when my brain gives me the information that I am looking at particular color, I am looking at particular object, and I have that particular distance from what I'm seeing right now. So those are the information that I extract from the view that I'm looking at. So similarly, using the gadgets that the computer have, it uses it to see the colors, to find the positions, and also to visualize the object so that he can use the information of the position, the spatial information and the colors to build something out of it, to construct some kind of scene. Luckily, we have built so many tools which is available to us, using which you can make a computer see what we see. Of course, our eyes are so sophisticated and more advanced, but definitely there are devices available who can do much more complex visualization of the thing. You can start with definitely the normal webcams. You can use the webcams and make a computer see what it wanted to see. There are other devices as well, which is Microsoft Connect, Asus, and Leap Motion. So these are the devices which actually gives you the power, your computer, the power to look at the things in a different way. If you talk about the Microsoft Connect, it has the different sensors, different cameras to look at something. Like it has the infrared sensor who can give you the depth of information, and it has the audio sensor using which it can listen to something, and it has also the normal cameras to extract the color information from the scene. Similarly, the SS1, and there is one more which is very new and going to be launched. It's the Leap Motion. This particular device has been designed, to track the hand movements, how you are moving your fingers. Right. So far now what we have discussed is we have given computer the power to see something, to get something out of it, but it cannot do anything until unless it has the power to process it. The data that is coming to the device is huge, and it's not stopping. The camera is just sending those data streams to the processors, right? So how do we process those data streams? Those data streams that we are talking right now, the video ones, is quite different from the normal stream that we worked upon, right? Every device has its own mechanism to send those data streams. So computer vision is something which does that data processing for us. It takes the raw streams, something like the color stream, depth, values, voices, and it does something and give us the information which is relevant to us, something like feature detection, motion tracking information, object construction, the visualization, and all. So what is this computer vision or CV? It is very important for us to understand what this computer vision is, because it is a field where you study and you do research on what kind of algorithm, what kind of things we have to do to process the image or the large size of data that we are talking about, to give essentially computer the vision that we kind of have. So it's a altogether a particular field, and definitely we have to understand certain concepts which is used, which is has been researched in computer vision. So the objective of the computer vision was to, get some information out of it, get the visual sense of what we are seeing, what we as a human see, and give that power to the computers. So common algorithms that you normally use to get that information from the basic ones are the age detection, blob detection, cascade classifiers, motion tracking and all, and also histogram. So these are a couple of algorithms kind of things which is there in the computer vision. People have done so many research in those areas to create a sophisticated and very powerful algorithm, and using which we can process our streams and extract those information. If you talk about the age detection, what it does, like we see canny age detection or the soul age detection, what it does, whatever the scene, whatever the stream that is coming to us, is trying to, get the information, get the edges from a particular scene, something like when you're looking at a building, to get the sense of the height and width of the building. If you could have known the edges, you could have easily identified the dimensions. So these kind of operators, these kind of algorithms gives us the power to do those things which is required. Okay. The blob detection. Blob detection is something where you have some random streams, random information to the stream, but definitely you want to pick out something like an arbitrary shape. The arbitrary shape could be, for an example, if you have a heap of coins and you want to just identify that heap, how big is the heap is, right? So that you can just think about it and process that information for some reason. There are a couple of transformations like Laplace transformation, Hood transformation, Gaussian filters, all those kind of linear filters available to help us in the blob detection. And those are the basic things which we need. And I will be talking about it later, that how can we use those things to create gestures, to implement gestures. There comes the cascade classification. Cascade classification is a form where you kind of create certain patterns, you put them into some kind of configuration, and how does those cascade classification classifiers works? They keep on, matching the coming streams for those patterns and find out the required information. Something like you have the Haar-like features where you can create the patterns for eye matching, and you can create several patterns from it. And when you implement these algorithms, what it does, it tries to match the coming input and find out the eyes from it, right? So this is something This is something the cascade classification does, and something similar in the motion tracking and analysis, which is essentially actually if you identified something, you have detected some object, then definitely you want to track it as well, so that it is basically done using the background extraction and finding out the relative position of the object which you have identified in previous sequences. So basically the motion tracking and analysis is part where which you need for gestures detection and all. There is one more thing which is related to the histograms. Histograms is something which gives you the distribution of the different data which is available in the streams. Sometimes you need it. Well, again, those are very complex things, and if you really think like you want to implement it, definitely you can implement it, but it's gonna take a lot of time. And we have the people, we have the people in the industries who have developed the frameworks and the APIs for us, using which we can just simply use those algorithms. We don't need to reinvent the wheel. We can just implement our functionality using those algorithms which has been developed by different frameworks. Some of them which is namely are OpenCV. OpenCV is a very wide group which does which has provided the implementation for different algorithms which you can use for computer vision application. Similarly, the simple CV, fast CV are there. OpenNI is one thing which is related to the natural user interface. It is an open framework which provides you the functionality to to do the gestures and all. NIT is one thing which is the natural interaction middleware, which works as a middleware between the Kinect or a similar kind of devices and the OpenNI. You can use it that way. Kinect also provides you SDK, which works for Windows, and you have to do minimal work and concentrate on your application, and you can easily create the hand swapping and other kind of stuff which has been provided by default in Kinect. It does provide the face tracking application, face detection API as well. So what do we do? Like, we have the tools, we have the algorithm with us, and we have the input stream. What do we do with that? Definitely we have extracted some information and we want to react to that information, right? So as you can see, now you can control the flow of your application. You can just do a swipe of your hand and you can change the content. You can do a push and you can click on something, right? It's very easy. So these kind of application can be created. So if you look at the screen for how the implementation flow for the gestures works, is you have the stream input with you. What you do next to it is you detect the different body parts like your hand. If you want to implement the hand with gesture, you can have the hand detected, and you keep on detecting it, you keep on tracking it in the next stage, so that you can evaluate the path, like how the hand has been moved from, let's say, left to right. Was there any variation? Was there any significant variations to it? And based on that, you can evaluate and you can determine if it was the gesture which I was looking for, because it's possible that you are moving your hand but in the opposite direction, or probably in the vertical direction, not in the horizontal direction. Yeah. So essentially what happens in this, you keep on getting the streams, you keep on processing the data, and you are collecting that information from one particular scene, one particular cycle. Keep on accumulating those information and create a gesture out of it. If it is not, then again. But what is essential, what is the difference in this kind of application, this kind of implementation is, your not stopping any movement, right? Something like we have in console-based application or grid-based application, graphical user interface. So in those applications, the user has to do the input. User has to initiate the interaction. But now what is happening? Camera is seeing what he has to see. He is continuously seeing those things. He is continuously, it's listening. And we have to extract those input information to us so that we can use those inputs and pass it along to the other external world where the gestures information needs to be used. There are certain points which we need to remember while we implement the gestures. We need to define the body joints and track them. So essentially what we are saying over here is I should be able to identify my, let's say, palm, and I should be able to track it. And then if I am able to track my palm, right, I can evaluate on top of that. So let's say if I say I want to evaluate a lag gesture. So if I have tracked all my fingers and my palm, I can do certain calculation to find out if there's a lag gesture. Lag gesture is something like a thumbs up gesture. There are two things to it. When you are evaluating a gesture, what you can do the algorithmic evaluation, something like whatever the string that is coming to you, you can process it every time. Or what you can do the pattern matching as well. Because sometimes what happens when you implement the gestures or postures, it is very difficult to create the mathematical logic out of it. It's very difficult. Something like you are doing something with your hand, one hand, and you are doing something very different with your other hand, and it is very difficult to create the mathematical equation out of it, the mathematical procedure for it. So what you do normally, you create the patterns, you record those patterns using the cams, the tools you have, and you save it. And in the real time, when someone is in front of the cams, you just match those patterns. So there are definitely pattern matching algorithm available, but it would be easier to implement once you have a very generic pattern matching algorithm to you, which you can tune to your application. So this is one of the way, but there is a trade-off between using the algorithmic versus the pattern matching, because you cannot have a very complex algorithm which takes time. On the other hand, you cannot save so many patterns that your performance is going down. So you have to choose between those two options. The other things which we should take care is the overlapping of gestures. We should not design such kind of gestures which is kind of contradicting. Like you have one hand in front of you doing something and you are extracting the gesture from it, and you just put some other object or your other hand in front of it, which will be blocking the view, right? This is one form, the blocking of thing. And the overlapping is also like you have two hands doing something else which can all overlap each other. So these kind of scenarios should be avoided. And while you do the implementation, we need to take care of so many things related to the external factors, which could be lightning, because what the camera is saying is passing to us, and depending upon what is the quality that is coming to us, we have to process it. So it varies with different lighting conditions. And also in the moving backgrounds, we have to consider the situation and think and design accordingly when we are having the application which is running in the moving backgrounds. That sometimes create problem. So we need to think about those external factors while we develop these kind of application. Then we move on to the challenges that we face. Definitely the unit testing is, when you develop this kind of application, you are first of all very dependent on the tools that you are using. They should be available. You need to adjust those things again and again to see how things are working, and it is very difficult to create the test data for it, right? Some of the tools definitely provide you something like Connect, which gives you the flexibility to create the test data, like record your streams, and you can play those streams on your application without moving yourself. So definitely unit testing is a challenge, but it can be overcome. There are other things like you can save those raw streams and you can process your application tools like MATLAB and all, but definitely that will restrict your technology options too. Dynamic external conditions. We have already talked about how it is difficult when you are working in extreme condition, something like in daylight, when the sun is on top of us. You don't want to be expose your cams, Kinects, or leave motion to those kind of conditions, because that is something which gives a problem with the color scheme that you get. Also, when you install multiple devices like multiple Kinects, you have the problems with the interference of different infrared. So the kind of information, the kind of streams that you get is also a challenge to read. Versatile human behavior. This is something which is very important to talk about, because this is also a very important thing to consider. Like, you try to create an application, you have to consider what kind of people you are expecting to use, and or rather I should say what kind of countries or geographies it will be used in. Because sometimes what happens, you design your natural user interface or your gesture which will be having a significant cultural meaning in one particular country but nothing in someone else, or maybe some kind of physical abuse, right? So definitely this is something which you need to consider. And also, natural user interface doesn't mean that you can create any kind, technically you can create any kind of gestures, but you should not be asking too much from your users. When I say that, what I mean is, let's say I am trying to implement the waving gesture. What happens? I should not be expecting, because my technical implementation will be very simple. If I just do a straight hands up on top of my head and then do the gesture, that will be very simple implementation to do. But that is something which I do not expect my consumer of the applications, right? They may do on the shoulder line, they may be a bit lower as well while doing the waves. So that is something kind of things which we should consider. The last but also important is the performance. So every device that we work upon has its limitation. It has its own field of view, and it works well in that particular field of view. It sees the information, it gives me detailed information out of it. But once I challenge those restrictions, the results will be different. Something like when you work on the Kinect, you have different modes available for you, which is the near mode and far mode. Let's say if you want to work on a very near mode application, working very closely to the interface, you can do it in Kinect, but definitely you cannot do it in very simple webcams. Or something about the far mode, right? The resolution goes down, the clarity of the data that we get is also goes down. So we need to make a trade-off what kind of application what we are building, and also on top of that what kind of resolution we want to have, which we want to process. Because at the moment you increase the resolution, the data and the rate at which the data that is coming to you goes down, right? So we have to make a trade-off between them. So those are the normal challenges that you face. One of the things which is not mentioned is the mounting of the solution as well, the deployment or the installation of the solution, because we have to consider the different scenarios. Like you have built your application while just sitting in front of the Kinect or Leap Motion, but what if your actual implementation, actual installation is going to be where you have no space for a face-to-face connect, right? Maybe you want it to be deployed on top of something. So all your calculation, all your implementation will go down. So that is something which we need to consider as well and implement accordingly. Consider those situations. Now, when we are done with the gesture creation or gesture implementation, it is important for us to know what are the things that was behind, and when we go further, what are the things which we need to understand or to learn to make our understanding much better than we have right now. Definitely, designing the natural user interface actions. As I've already talked about, we should be considering the different locale, culture, information and all, and the behaviors of the people before making any without making any assumptions. So that is something which we should read through, computer vision fundamentals. So I have skipped that part when we were doing the gesture based implementation, the flow that we were looking at, but we should definitely have a look at the computer vision fundamentals and how it works. Something like how normal edge detection works. How do they do? So usually what happens, you come up with your stream, you have your stream, but what do you do with that? How does it work normally? So definitely we should have a background to it before proceeding further, so that it makes us much more comfortable. So taking an example like how edge detection works, what it does, it takes the particular portion of the image or the area of concern for us and it try to build up the gradient vector. What is gradient vector? Gradient vector is something like how the intensity of the color or the value of the color is flowing, right? So in that particular region, and based on that, if there is significant change in the intensity, it catches it as an edge. So that is something which we will learn when we go through the computer vision fundamentals, and I definitely recommend that. And definitely there is a mathematical learning as well. We need to go through the bit of linear algebra, like how matrix works, because it's all about matrix. The inverse, the transformation, linear filters, everything works on matrix. So definitely we should look at that. And how the projections, how the different planes work, the 3D model, and how the depths are being calculated, everything. And remember that if you are having multiple devices using which you want to process something like kind of 3D thing, consider the depth, the infrared interference into picture. How you gonna use your gesture based application? Maybe you should look at the graphics programming. This is also useful because how you gonna show, right? Show the output to the world. Maybe it can be a normal window graphic application or something much more complicated. So definitely a beginner's hand is required on that part. And bit of basic physics, if you are working on any of the games application to involve the gestures, definitely reading for the basic physics will be required. So I think those are the key points which we wanted to discuss. We can definitely start picking up any of the tools that we have. We can start with the simple webcam and any of the open frameworks which we have, like OpenCV. Just try to create some application out of it and see how it works. Thank you. I think I'm pretty much done. I'm open to any questions. Okay, so there is one question from Amit X, which is, let me read it out. Can you share any examples of large commercial deployments of gesture programming in natural user interface? Okay, so there are very complex applications that has been built in medical fields, where you can just use your gestures to just see the different angles, different views of a particular, let's say, the brain, let's say. So people are using in the medical field as well. There is one more example where you can use where people are using it in the where you can use it in the sign language, where the people who cannot speak or listen can use the sign language and communicate to the normal human beings. Those are the applications which has been used. Okay, the next question is, can you please summarize? Can you be a bit more mm, clear, like what exactly is this question, and I can definitely take it up. And similar to the intent for the, can you share examples with automotive industry? Okay, meanwhile I can take up the other question, which is is this capability linked, integrated on smartphones? In other words, can we have any application put onto a smartphone? Definitely. I think this is a very good question, and definitely we can put the NUI applications into smartphone. If you see there is already some ads going on for the Samsung Galaxy S4, where they have implemented the eye blink and also some part of the face tracking. When you watch some video and you just move your head, put yourself out of focus, it will stop. So definitely there are applications available. There are things which is using in the smartphones, and also like frameworks like OpenShift and all, they are exposed for the iOS and other platforms. So you can definitely build up any AI application, but it will be a challenge to uh, build those applications, because you have to define your gesture pretty very cautiously. You cannot use all your body parts for that, right? The next question is, can the data from a sensor be streamed over HTTP to be handled by a remote app? Well, this will be a huge data, right? So I would suggest we should not just stream over all the data, but what we can do, we can create a service kind of stuff, right, where it is getting all the information from the sensor and extract all the information and pass it over. And there are a couple of JavaScript libraries for the natural user interface is available. but we need to check the performance of that. But those JavaScript frameworks gives you the flexibility to, working on the web apps using the cams on the client browser. Yeah. One of the questions that I see is which tool do I use to do the programming? Well, are you probably talking about the language, or what? Okay, so maybe tools wise I can take up like you can use the Connect SDK, and definitely you can work upon the normal working on the C# application using the WPF and all. So definitely that can be one solution. You can also work on the use any of the framework which is like OpenCV, and can work on the iOS or Java and all. Are these Xbox games, are these part of same? Yeah, definitely those Xbox games are same, but definitely you need to check like how the visualization has been implemented, because the Kinect is the same, the processing of the gestures is the same. Only thing which is different is the UI part, which is actually developed in Unity. Can I do this in Xcode? Definitely you can use the Xcode as well. You can start with the OpenCV thing. Or does it need a local SDK and local app? Well, if you are saying okay, the asker is Rupal Mazumdar. It asks, like, does it need a local SDK and local app? For most of the part, my answer would be yes. But if you can minimize the data that is available on the client side, which you want to pass it to the, your remote one, then can definitely do it. But it will be a challenge that I see. There is one question from Parul Vansal. It says, how can I capture fingers? Okay. To capture fingers, what you can do, you can first capture the contour of the palm region, and on that palm region you can identify the different edges for the fingers, and that should be a start point for us. One of the questions that I see from Prashant Nandanuru is how different it is from augmented reality. So from the top view it looks like to be the same, but augmented reality is something that is totally different. It may be processing something, but not the movements, right? In here you are actually tracking the movements, doing some calculation analysis. And in augmented reality, what happens most of the time, if you see some kind of object, and on the object you detect it and you do something, you superimpose something on your screen, right? The next question again is from Parul Bansal, who says, is it possible to use Connect with language other than .NET? Definitely you can use Connect with language other than .NET. You can use the OpenNI is a framework for your natural user interface, which provides the gestures for hand swap and others. And on top of that, you can use the Night middleware to interact with Connect sensor, which is essentially called this Sensor Connect. There is one module in the OpenNI which is the Sensor Connect. Geeta S. How unit testing become a challenge in these kind of application? So, okay. So when I say you will face a challenge in unit testing, what I meant was you have an application, you have some tool set up on your desk. Every time you want to test something, you have to do that gesture, right? And that is very, very difficult sometimes. You cannot reproduce certain kind of test data again and again from yourself. So what you normally do, and also it's not possible for you to create the different exposure conditions and also the dynamic behavior of different people, right? So what you normally do, you record those things, get it exposed to different people, record those things and test it over. So that is how you normally do. But it depends upon the tool, if it is provided that information, or the technology that you are working upon. Sometimes it's possible with, if you're using C, C++, you can use any tool to save the raw stream to your disk and then process it into MATLAB API using the MATLAB APIs. Sumit Sharma. Sumit Sharma asks, also what are the technology and framework used to develop such application? I think that has already been answered. You can use .NET, you can use the C++, Java, Python, right? Most of the open framework that we have seen, like OpenCV, Simple CV, Fast CV, those kind of frameworks are mostly compatible with, mostly implemented for different platforms. Which languages provide good API for build gesture application? Jatin Patel has asked this question. I think I have already answered it, but again, if you look at the Connect is best when you are using when you are building some application on Windows, right? It provides you the very complete SDK, and it also has the face tracking API as well. So you have to do nothing but to just use those things, and on top of that you can build upon your logic to process something like in Connect. You don't have option for eye blinking, right? It doesn't provide as of now, but what you can do, you can implement that, but you can get the face tracking initially done by Connect. Shumi Sharma has asked, can you please explain how data flow in such system? What kind of data sensor provides? Okay, that's a the question. So the question is how the data flows in such kind of system. So when I was talking about the data stream, what I mean is you have the raw streams, the raw bit stream, right, which has certain information which has been added by the different sensors like header, which tells like which portion of the stream I'm going to use it for color, which portion of the stream I'm going to use it for depth and all. Not for depth, but in the color, like what portion I am using for RGB component. So that is particular kind of segments they normally provide in the documentation and all, and based on that you do your stream analysis. And the data that they provide normally you have different sensors for providing different data. Like you have the infrared sensor for having the depth data, you have the cams, RGB cams for your color streams, you provide the microphones for your voices. Are there any simulators for doing the development? This question has been asked by Paul. Are there any simulators for doing the development? Simulator in so well, this question, to answer this question, my thing is like there is no device constant, right? But you can definitely have the different kind of data source saved, data streams saved prior to working on that application. That can be used for simulating your data, because the most challenge is not the device simulation but probably the data simulation. So you can definitely, once you can save it and then you can use it. Okay. Rupal Mazumdar has asked one question, which is, can one develop Connect apps using Microsoft SDK for commercial use or only for non-commercial use? Do you know what licensing is involved for commercial app development? Well, they have provided the SDK for use. You can definitely use it. Earlier it was not available, but at the time where Connect was launched, people were already people was already able to get all the information they required. They created their own API. Even if you don't want to use the Microsoft SDK, you can definitely use the OpenAI and Night to do your work, which is very advanced as well. Because there are certain things which is not available in the Connect SDK. Is, is there any limitation of gesture at one moment of time? Well, I think this question is, maybe you can clarify more. What are the limitations that you're talking about? Okay. Okay, so one of the question is there any limitation of gesture at one moment of time, like the number of people it can track at one particular point of time? Okay, so it depends upon the what tool or devices you're using, and what, not the device, but what SDK or computer vision library you're using. Something like in Connect, you can have 6 faces detected, but you can track only 2 of them, right? So it depends upon how advanced your API is, and you can definitely use open frameworks to implement your own. Can we use Connect with HTML5? Well, yes, if you have the HTML5, you're talking about the web browser application. Then somehow, if you can, pass the filtered information or the extracted information about gesture, you can definitely use it in HTML5. But otherwise, I don't say like you should. I would not suggest that you directly use Connect data on client, right? Would be too heavy to handle. Your point of view, which language is best for gesture application? Jatin Patel has asked this question. Well, it depends which language you are comfortable with, because most of the open frameworks are available in the modern languages that we use, like C, C++, Java, .NET. But if you talk about my point of view, I would recommend to go with C, C++, because you have more control over the lifetime of the objects, so that you can control the objects, the time and space complexity and all, right? Can you explain what is open framework? Okay, so when I say open framework, I was talking about the different open source computer vision libraries that you have, using which you can process the data stream that is coming from different sensors. So OpenCV is one of them, SimpleCV is one of them, FastCV is there, Connect SDK is there, right? How can I use Connect on Mac? Parul Bansal, I have already answered this question. The question, okay, but again I can tell you, you can use Connect as a normal sensor source, the stream source, and you can use OpenAI and you can use Night to do that thing. Yep. Okay.
I think that's all from the audience.
Yep.
It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgeek.com by tomorrow. Thank you all.